when we said when you were adding two functions, you could just take the derivative of each and add them? Turns out it doesn't work that way when you're multiplying two functions together. I can't just take the derivative of that and take the derivative of that and multiply them together. Bummer, doesn't work. So we learned this product rule. And there's a ton of ways to memorize it, but the gist is you're going to take the derivative of one of these functions, leave the other alone, and then vice versa. And you're going to add those pieces together. So my teacher always said the first times the derivative of the second plus the second times the derivative of the first. Now I've just come to do take the derivative of the first guy first, leave the other alone, then add the opposite. These functions are all kind of boring here because you always do have the option. You might be saying just, hey, why don't I just multiply that out first, right? Why don't I just say, haven't taken a derivative yet, why don't I just say that this is negative 3x to the 7th plus 2x cubed and take the derivative of that with just a normal power rule. And I don't need any product rule, right? It's like, yeah. Don't need it. But if you want to compare it to this new product rule, because later on when you do different functions, you're going to need it. So we'll try it with this new fancy rule, see if we match that. So we're saying for our derivative, we're going to take the derivative of the first piece first, so that negative 3x squared, leave that other piece alone, 3x to the 4th minus 2, and then add the reverse. So leave the first piece alone, and take the derivative of the second piece, so times 12x cubed. And then just clean this up, so distribute negative 9x to the 6th plus 6x squared minus 12x to the 6th. Minus 9x to the 6th minus 12x to the 6th is minus 21x to the 6th plus 6x squared. Hey, look, we match, how exciting. And so I'll do the rest of those just like that.